Hey everyone, and welcome back to the channel. Today, we're diving deep into one of the most influential and enduring programming languages in the world. Java. You've probably heard of it. Maybe you've even written a hello world program in it. But what really makes Java tick? Why has it remained a dominant force in the software industry for decades? Let's find out. Our story begins in the early 1990s. A team of engineers at Sun Microsystems, led by the legendary James Gosling, was working on a project codenamed Do. Their goal was to create a new language for smart consumer electronics, like interactive television set-top boxes. The language needed to be simple, robust, and, most importantly, portable. It had to run on any kind of device, regardless of its underlying hardware. This core idea, write once, run anywhere, became Java's mantra. By 1995, Oak was renamed Java, and with the explosion of the World Wide Web, it found its true calling not in TVS, but in building dynamic, interactive web applications. Sun Microsystems released Java 1.0 in 1996, and the rest, as they say, is history. So, what's the secret sauce behind Write Once, Run Anywhere? It's a brilliant piece of technology called the Java Virtual Machine, or JVM. Think of the JVM as a computer inside your computer, a standardized virtual environment. When you compile your Java code, it doesn't turn into machine code for your specific processor like C++ does. Instead, it compiles into a special intermediate format called bytecode. This bytecode is a universal language that any JVM on any operating system, Windows, Mac OS, Linux, you name it, can understand and execute. This abstraction is what gives Java its incredible portability and has been a cornerstone of its success. But the JVM is more than just a simple interpreter. It's an incredibly sophisticated performance engine. One of its most powerful features is the just-in-time, or JIT, compiler. When your Java program starts, the JVM begins by interpreting the bytecode. As it runs, it identifies the hotspots, the pieces of code that are executed most frequently. The JIT compiler then takes these hotspots and compiles them into highly optimized native machine code on the fly. This means your application actually gets faster the longer it runs. It's like upgrading your car's engine while you're driving down the highway. Another lifesaver built into the JVM is automatic memory management, thanks to the garbage collector. In languages like C or C++, developers have to manually allocate and deallocate memory. Forgetting to free up memory can lead to memory leaks, which can crash your application. Java's garbage collector automates this entire process. It periodically scans the memory, identifies objects that are no longer being used, and reclaims that space. Modern JVMs have incredibly advanced, low-latency garbage collectors like G1 and ZGC, which can manage huge amounts of memory with almost imperceptible pauses, making Java suitable for even the most demanding, high-performance applications. This powerful and stable foundation made Java the perfect choice for building large-scale, enterprise-level systems. And when you talk about enterprise Java, you have to talk about the Spring framework. Spring started as a lighter, more flexible alternative to the complex Java standards of the early 2000s. It introduced concepts like dependency injection and aspect-oriented programming, which made building and testing massive applications much easier. Today, the Spring ecosystem is vast. If you're building a web application, you likely use Spring MVC to handle web requests, and Spring Boot to get your application up and running with minimal configuration. Need to talk to a database. Spring Data makes database access incredibly simple, whether you're using a traditional SQL database or a modern NoSQL one. What about security? Spring Security is the gold standard for handling authentication and authorization, protecting your application from common threats. Spring has become the de facto standard for building robust, scalable backend services in the Java world. The proof of Java's power is all around us. You might be surprised to learn how much of your digital life runs on Java. The entire Android operating system is built on a foundation of Java. When you use Google services like Gmail or Google Docs, you're interacting with massive Java-based backend systems. Financial institutions and Wall Street trading platforms rely on Java for its performance and reliability to handle billions of transactions. E-commerce giants like Amazon use Java to power their back-end services, from inventory management to order processing. Even creative tools like Minecraft were originally written in Java, showcasing its versatility. It's the invisible workhorse behind a huge portion of the digital world. Of course, Java isn't the only language out there. How does it stack up against other popular choices? Let's take Python. Python is celebrated for its simplicity and readability, making it a fantastic language for beginners, data science, and rapid prototyping. However, when it comes to raw performance for large, concurrent systems, Java's compiled nature and highly optimized JVM often give it a significant edge. Then there's C#, developed by Microsoft. C# and Java are very similar in syntax and design philosophy. C# was heavily inspired by Java. Both are statically typed, object-oriented, and run in a managed environment. The biggest difference historically was the ecosystem. Java was built on open standards and runs everywhere, while C# was traditionally tied to the Windows ecosystem, with the rise of NetCore and now NET. C# has become much more cross-platform, making the choice between them often a matter of company preference, existing infrastructure, and the specific frameworks you want to use. So, with all these new languages, is Java a thing of the past? Absolutely not. Java is evolving faster than ever. Oracle, which now stewards Java's development, has moved to a 6-month release cycle for new JDK versions. This means new features and performance improvements are constantly being delivered to developers. One of the most exciting future developments is Project Loom. A major challenge in modern software is handling tens of thousands of concurrent users. Traditionally, this meant using one operating system thread per request, which is very resource-intensive. Project Loom introduces virtual threads or fibers, which are incredibly lightweight. This will allow developers to write simple, straightforward code that can scale to millions of concurrent operations with ease. Revolutionizing how we build high-throughput applications in Java, recent JDK releases have already brought amazing features like records for creating concise data classes, pattern matching to simplify complex conditional logic, and sealed classes for more control over your class hierarchies. These updates are making the language more modern, expressive, and enjoyable to use without sacrificing the performance and stability it's known for. In conclusion, Java's legacy is built on the brilliant vision of Write Once, Run Anywhere, brought to life by the powerful JVM. Its robust ecosystem, led by frameworks like Spring, has made it the backbone of enterprise software, e-commerce, and finance. And with a rapid release cycle and groundbreaking projects like Loom on the horizon, Java is not just surviving. It's thriving and continuing to shape the future of software development. It's a language with a rich past and an incredibly bright future. Thanks so much for watching. If you found this deep dive into Java interesting, be sure to hit that like button and subscribe for more content. Let me know in the comments what language you'd like to see me cover next. See you in the next one.